you could classify metals based off of their density.
Welcome to Lively Materials. What she said, like, do you know that it's possible for us to classify metals based on their density?
So we're repping Africa today. Most of the metals in the world are found in Africa, so up Africa.
Don't allow Russia and China and the US to come for you. There are quite a reasonable amount of metallic ores in those areas as well. But of course, most of the critical minerals now are, residing in Africa, so that's good.
So we're going to be talking today about heavy metals, light metals, and liquid metals. The first thing we're going to be starting on is the classification of these metals. How do we classify heavy metal, a liquid metal, and a light metal?
If you look at the periodic table, we have more metallic elements than the non-metallic elements. And okay, let's go to it. Yes, now we want to classify metals based on their density. Density of metals is based on the atomic mass of the metals. Atomic mass is the sum of the proton and the neutron. The atomic mass alone does not determine the density of materials, basically, and not only the atomic mass of the atom of the metallic element, but also how the atoms are arranged and packed. We can look at the sum of the different metals that we have. Indium, magnesium, and titanium. They have much lower density, and we classify them as light metals. Okay? We have lithium. It's also a metal, and the density is about 0.5, but it is not considered a structural metal, but we use it in battery applications. It's one of the critical materials that we need today. Okay, if we are actually moving from fossil fuel to renewable energy systems, we need lithium, and that's why you should study metals. Okay, study metallurgy when you get to the university. So basically, light metals are metals that have low density. Example is aluminium, another one is magnesium, another one is titanium. These three are structural light metals. That is, you can use them to build structures. Titanium can be used in the manufacturing of plane aerospace engines. They are used in human bodies as implants. Aluminium can be used for buildings, your window frames and rails and quite pots at home, your cooking utensils. You can make them from aluminium, and the density of aluminium is 2.7 grams per cm cube. The density of titanium is 4.5 grams per cm cube, and magnesium, which is the lightest structural metal, the density is around 1.6 to 1.7 grams per cm cube, basically, depending on the purity and depending on whether you have some impurities in the material or not. Oh, let's not talk about heavy metals. Heavy metals are those ones you don't even want in your body because they can be very poisonous. Example, we have lead. It's a heavy metal. Okay, arsenic is an heavy metal. It's actually an example of a heavy metal. Iron is a heavy metal, and from iron you can make steel, and it makes it a heavy metal. And again, apart from the metals that I've mentioned earlier, which is magnesium, aluminium, and titanium, all the structural metals are heavy metals because their density are from 5 grams per cm cube and above. Okay, density tells you whether they are light or they are heavy. So with titanium, which happens to be the benchmark between the heavy and the light one, has density of 4.51 grams per cm cube, like I said the other time. By the time you start moving from 5 grams per cm cube and higher, then you're talking about heavy metals. I hope that is clear.
So apart from density, how else can we classify metals?
There are some metals that are liquid at ambient temperatures, at room temperatures. For example, mercury. Mercury actually exists as liquid metal. At room temperature, it's actually liquid. And that's why we could actually use it in our thermometer to measure temperatures. Okay, mercury is not the only one it's not the only metal that we could classify as liquid metal. Gallium, for example, and cesium, for example, are also liquid metal at about, at ambient temperature. So the melting point of gallium and cesium is around between 28 and 30 degrees Celsius for both. You could have gallium, cesium, and mercury existing as liquid metals, right? So you can see that, science is really fun and the knowledge of metals is quite interesting. So we just want to get you lively, and I hope that this is getting you excited. You can just listen to our voices and you get to know about metals and how you could classify them, and based on density and based on the state of matter at room temperature, at ambient temperature. There are other classifications that we will still talk about, especially when we consider the different applications that we use metals for. Then you would see how science of metals is so fascinating and diverse. And for those that are in Southern Africa where you don't write WAEC, we call it matric here. So this is an exciting opportunity for you to know about the important materials that have made our world look so beautiful now. So, if you're undecided about what to study, just go for the study of metals, which is called metallurgy or material science in different universities.
So please do ensure you like, share, and subscribe to our YouTube channel. Follow us on Instagram, follow us on TikTok. This brings us to the end of this episode, and make sure you do please stay lively.
Stay lively, guys.
Stay lively.